Kul att ni är här. Gustaf, Eneroth heter jag, kommer från Mockom, en del utav automotive-gruppen. Och jag ska prata om återvunna polymera material i bilar och elektriska applikationer. Kan jag fortsätta på svenska? Or do you want me to take it in English? Continue in English? Okay, I'll switch over to English, no problem. I think that's fine for the rest of the audience as well. As I said, I'm coming from Mockom, which is part of automotive Group. It's a German family-owned company. It's roughly a turnover of 1.5 billion euro in the group. It's still driven by the family. So Philip Kran is the CEO of the group. And we are here at Elmia in C Hall, CO26, I think it is, in the hall number 1. Where you can come also after the presentation and talk to me. I mainly work for Mockom and for VPAG, where we do circular solutions, which I will show, and Mockom, where we do both fossil-based and recycled polymer solutions. At Mockom, we have production facilities in Europe, North America, and in China. So many of our customers that I work with, me myself, I'm a mechanical engineer in my background, but I turned over to the polymer side after being at both Volvo and Nokia in the past. So I have a mechanical engineering background, and that's why I normally talk about the application developments, not so much about the chemistry behind it. That's what I have my colleagues in Germany who are, they have doctor titles and white robes in there when they go to our office. But we are present in North America, in Europe, and in China. If you are also present there, I see some of the audience are global companies. We have recycled polymers in our portfolio, but we also have fossil-based and bio-based products. But today I will focus on some real examples from the automotive industry and from the electronics industry, and some different the questions that customers have to answer or face if they start looking at recycled products. What should they choose? What is the feedstock? What is maybe the future feedstock, and what is it competing with? What colors can we do, etc. We won't be able to answer all the questions for maybe your product today, but I will at least lift them up to the surface. This is a very complex image. It's basically telling what is happening with polymers from they are produced into they are turned into a product, they are used in its product, and then it's recycled in either a post-industrial recycled circle or in a post-consumer recycled circle. And what has happened the last 2 years? You can see that in Europe, the total production has gone down 10%, but the recycling has improved 10% only in 2 years. So we are in a transition where there is a lot of things happening. We also see that a lot of the thing is being exported, but it's also decreasing. And some is still going to landfill. A lot is going into energy. But this is a very complex, we can't talk about it today, but this is more or less showing the picture of what is happening with the recycled plastics. And you can see that there are also many new variants coming in. The chemically recycled feedstock, the bio-based feedstock, and also some new emerging technologies like carbon capture and utilization, dissolution, and other new technologies to produce a polymer from a monomer. These are the basic big variants, and maybe you have been facing them. We all hear about them. We have the mechanically recycled feedstocks, which is this stuff, which is the things that has been a product before. It can also look like this, if it's a post-industrial, some scrap from an industrial process. Or it can look like yarns. It can be different types of feedstock that it has been in before. Or it can be packaging. Packaging waste is a big feedstock for mechanically recycled solutions. The mechanically post-industrial recycled feedstock is often cleaner. So if we compare these two, the mechanically post-industrial recycled feedstock is often cleaner. You can maybe use it in more extent in an interior of a vehicle for more advanced solutions, whereas maybe the different or the availability is bigger in the post-consumer recycled feedstock. If we go over to biocomposites, which is it's a hot polymer material today. It reduces, if you can capture carbon in the biocomposites or in the wood or in the the natural fiber that you put into the polymer, you often can have a very low initial carbon footprint of your polymer when it leaves your factory. The negative thing is that these natural fibers are really difficult to recycle in a good way. So I sometimes compare it with, it's like peeing on your foot, that it gets warm in the beginning, but it's getting maybe cold when you have to take care of your own product. Chemical recycling is another thing. You can actually turn a polymer from its base chained molecules and bring it back to where it once was. So making a new material with the chemical recycling. And this is really, the benefit here is that you get new material properties. You can use it for food contact applications, medical applications, but it's energy consumption. So you have, and you also, when you use energy, it's also gonna cost more. The mechanically recycled solution, whether it's post-consumer or post-industrial, will be cheaper than the chemical and the bio-waste and the bio-based currently. If we go over to, and now I'm just touching really some of the core properties here, there may be different depending on your application. For example, in automotive, it's more difficult to put a post-consumer recycled material that has been in contact maybe with garbage in the interior, but it doesn't matter if it's placed outside of the vehicle. So bio-waste is another often used feedstock for low carbon footprint products today. And it's really a great feedstock. It's often coming from food waste or post-consumer used food products, like cooking oil and other products. But it's also competing. It's the same feedstock that goes into the bio-waste polymers that is used in the diesel that is put into our, what we put into our cars. So it's actually, there you have quite a competition of the feedstock because it's often used in other applications as well. Because once it's turned from the bio-waste, it can be used either as a fuel or a polymer, but the advantage is that in chemical recycling and bio-waste, and sometimes in bio-based, you have drop-in solutions. Maybe you do not have to consider a loss in properties that maybe you have in the mechanical post-recycled, or adjusting maybe for a wider color tolerance, etc. With these technologies, you have prime material, but the feedstock is coming from waste or bio-based sources. So the bio-based sources is another feedstock. We have bio-based materials in our portfolio as well, but also there, the total bio-based production capacity today is, I think, 0.5% of the total polymer production capabilities. So, but there are investments in place, but the volumes that are being put out of these different feedstocks is much lower. But in the future, we will need all these technologies. We will need better sorting of mechanical post-recycled solutions. We have need better sorting of industrial feedstock. We're going to need biocombustible. We're going to need bio-waste products. We're going to need to take the value of the waste that we have, whether it's industrial or consumer waste. Then there's some new small emerging technologies like carbon capture and utilization, dissolution, and other technologies that will add to the whole spectrum. But it's not easy to just say, okay, let's go for a sustainable solution or a recycled solution, because this is the type of questions that what kind of feedstock. Previously, if it's a fossil-based, it was, yeah, it's a fossil-based solution, feedstock. But now it's more, okay, should we choose what kind of material should we choose? Should it be mechanically or bio-based or bio-waste or another technology? And this is what we can help with at both MOCOM and ALBIS, because we have the different materials in our portfolio. But today, I will more focus on the mechanically recycled and the industrial recycled solutions. So what we have is really a lot of different product portfolios. We have the advanced specialties with flame retardants, with where we do colors, bright colors, with maybe added effects like anti-squeak for the interior in an automotive, or flame retardants, or special glass fibers, or other things to add the performance in a compound or in the product. When they have more standard, near to prime solutions, we have elastomers, we have recycled carbon fibers, where we take the carbon fibers from industrial processes, because when you do vacuum-shaped carbon fiber products, you often have a lot of cut-offs, and we turn the cut-offs, and we make injection molding grades out of that carbon fiber. So it's a very also cost-efficient way of making metal replacement products. We also do recycling as a service. So this is where we, for example, for automotive suppliers, this is, for example, an instrument panel, a cutout from an instrument panel. It uses glass fiber reinforced polypropylene, or polyurethane foam, and a polyurethane skin. And we actually collect these waste from the supplier, and we take the waste back to our factories, and we separate the three different fractions. So we work with a lot of customers in mainly right now in automotive, but we are expanding this portfolio as well, to recycle their materials, whether it's been used by a customer, so they are collecting it, or if it's something which is a scrap from their own process. Then we have some more industrial type of grades, and we also have Vipelast and Vipaflex, which are they are two products which has been automotive products. They are based from bumpers and the shredder light fraction. The shredder light fraction is what you see here. It's really when you have a car which is used, they remove the batteries and the liquids, and then you shred more or less the whole vehicle, unless you take away some of the parts before. And then you end up with a fraction which is wood, polymers, electric cables, and everything. And then from this one, we separate polyolefins into a compound which can be used for undershield bodies, wheel arch liners over the wheels, and other parts with the lower, but if you could take other materials out before you shred everything and mix it, then you would have better different fractions. We do colors. Many times you hear you can't do colors, but you can. This is, for example, post-consumer recycled polypropylene in gray and black. You can buy it from us tomorrow. We have transparent polycarbonates. We have natural colored nylons. We have, more or less everything. And we can also do the specialties, so adding laser marking effects and other color effects to our products. These are 4 examples of implemented and running industrial solutions in automotive today. And the first one is more to show that a recycled material can go into a quite demanding application where you need hydrolysis resistant nylon, you need strength and stiffness, and this is 35% glass fiber filled nylon 6/6 for Ford, where actually Ford is using our nylons in all their cam covers as well. And this is reducing the carbon footprint in this product by 90%. And this is mainly coming from a nylon 6/6 is quite energy or CO2 intensive to produce. It's quite high global warming potential of nylons. We have PCABS going into the Evoco. We actually also supply this illuminated material or the material for the illuminated ring. This is reducing it by 60%. We also supply the polycarbonate for the Fairphone back covers in China, produced in China. And for this one, this is more or less 2 kilos per car in the Volvo XC40, the C40, and the V60. This is a polypropylene that passes all the emission, smell requirements, and everything. And it reduces the carbon footprint by 40%. And it's roughly 70% of recycled content in this polypropylene. So it's already there. You can have different solutions that are already in place at a lot of different big customers. We have 300 different grades, recycled grades at Mocom. So these are just a couple of different solutions where you can see where it's been implemented. But then we can always discuss your application and your requirements in your case. I want to spend the last minutes to just talk about some of the EV charging and emerging electric vehicle. We have a lot of materials both for EV charging stations but also for battery applications. So for applications inside the battery, not for the battery cell itself, because there you mainly use it's just a separator in the battery cell itself. But for surrounding applications, for the battery management systems, for the DC-DC converters, for all the different parts that hold the back together, or the pack, there we have recycled solutions to, and they can be either in our Alcom grades or Altec Eco grades or recycled PPS, high temperature grades, or it can also be that you are replacing a nylon solution with a prime polypropylene solution. Because what we have gone from the last couple of years is a discussion about adding recycled content into the car. We're going into a reality where we're talking about the actual carbon footprint of the material. It doesn't matter if it's fossil-based, bio-based, mechanically recycled, bio-waste, etc. What matters is the actual footprint. And if you can save replacing a nylon 6 or 6/6 with a polypropylene, high-temperature polypropylene, that's a decrease in carbon footprint as well. So you can also be thinking of solutions where you can replace a current carbon fossil-based solution with another fossil-based solution where you can save CO2. Yeah, these are some examples of our grades for charging stations. We have many implemented also polypropylenes in battery applications at OEMs. So I think that was that. I have 1 minute left, so this is just showing what I lifted up here before. I don't know if it walked around this part from the instrument panel, but this is how it looks more or less before we do more things to it. And we actually separate all these fractions. You can pass it around. The other bags are a little bit too dirty, but you can come up after the presentation and look at these samples as well. So what we actually do here, we use a lot of our different processes to separate, clean, and separate different fragments. We can actually separate a 2K shot hard and soft material mechanically. So you can get, even if you have a 2K made material, we can separate the elastomer from the hard polymer. And we can remove the paint from exterior painted parts. And this is what we actually do with this shredder light fraction, where we turn it into a polyolefin solution. It doesn't have the same properties, so this is the important stuff. If you can separate parts before you put them into a big pile, you have a much wider processing or product when you mix all the materials, compared to if you can take away these materials from the beginning and sort them. So what we are doing right now is that we are looking for all other parts in the vehicle, mainly in the vehicle, but also in other industries. We are using headlights as a feedstock for polycarbonates. We are using interior parts as a feedstock for polypropylenes, etc. And we are doing this on an industrial scale. This is not lab scale implementations. This is at least 10 ton at a time to have it industrial, so that it can be competing with a fossil-based solution. So I think this is, I've used my 20 minutes, but if you want to come up and have a more look on some big samples, or come over to our stand in Hall C, space number 26, we can give you more detailed information about all these applications, and more of our 300 different materials. Any questions right now from the audience? 20 minutes is a short time to discuss, but you are more than welcome to come up and grab a business card or have a look at some of the parts or products here. Okay, thank you.